My name is Associate Professor Bing Wang at School of Public Health and Preventive Medicine, Monash University. I'm a basic researcher, and so my focus is in research, and all the students I have are postgraduate and undergraduate research students. So my teaching is mainly focused on research graduate students like honors, master, and PhD, because I'm a research-only position conducting research in the cardiovascular pharmacology fields, and my students are mainly interested in the research field already do. So that's my focus in terms of teaching at Monash University. The most probably enjoy is nothing better than you see the students' achievements when they achieve the goals they set for themselves, and also we can, when we can transfer the knowledge and skills to them, and they learn in a fast pace and achieve the outcome, and also taking on those skills and knowledge in their career. So that is my most satisfying things to do. My research is focused on cardiac and renal pharmacology. So we study from the cellular model all the way to clinical trials. So we develop using the background knowledge we have in terms of medicinal chemistry, drug design, and testing them in cellular model and then animal model. We also have a clinical studies including biomarkers discovery for diagnostic and prognostic purpose. So that's true translational research across the spectrum of cellular and bench-based study all the way to clinical study in public health policy. My research output, there are a couple of highlights over the last few years of my research. This including we are the first group to discover urea-toxins' detrimental effect to cardiac system. So urea-toxins are the toxins that cannot be excreted out in the chronic kidney disease patients when they develop chronic kidney disease, and those toxins bind to protein in high affinity, and normal dialysis cannot be separate them out from the circulating system, and they directly cause cardiac hypertrophy and cardiac fibrosis, and they lead to heart failure. So that is one of the discovery we think is very useful, and we are working on methods to try to eliminate such a detrimental effect, hopefully to develop new therapies for kidney disease, comorbid heart failure. The second most exciting discovery is the discovery for the first time of enzymes that's governing the synthesis of sphingolipids that convert dihydrocellulamide to celulamide, and we found the inhibitor of these enzymes are having anti-fibrotic effects. And currently there's about 60% of the people dying of fibrosis disease, but there's no selective inhibitors or selective treatments for this disease. So we hope to develop this as a novel therapy for fibrosis disease. First of all, I have to thank our late great Professor Henry Krum to give me the opportunity for working with the School of Public Health. He not only just gave me the opportunity, also gave me great mentorships for me to conduct research, not just in basic on the bench, also clinical related research. So my background is I training as a chemist in China in chemistry and master and bachelor degrees, and I conduct my PhD studies on protein kinase and protein kinase inhibitors. After my PhD study, I found a lot of those protein kinase inhibitors, and so the uses of those inhibitors will be as a therapy for various diseases, and therefore my first PhD position I took up is at the Baker's Heart Research Institute to conduct cardiovascular research, hoping to utilize those protein kinase inhibitors as a new therapy. And since then, I also involving in a biotech company to discover new drugs. And Professor Henry Krum gave me the opportunity to come back from the industry into academia to do research that is further utilize this, and therefore I am in an environment where a lot of clinical and clinicians who conduct clinical research, so I get this opportunity to conduct basic research, which is focused clinical applications.